Okay guys, in today's fun and exciting video, what we're going to do is we're going to talk about the difference between two very special physical quantities. Okay, one is distance and the other is displacement. So we're going to outline some differences between the two, and I'll run through an example with you to emphasize those differences. Okay, so one major difference is that the distance is a scalar quantity. Okay, it has no direction. That doesn't mean it doesn't have any direction in life. It just means that it's a quantity that has no direction specified, such as north, south, east, west, left, right, forward, backward. None of that. It's just a magnitude or a size or an amount. So, for example, a distance could be 10 meters. Okay, so for example, I could say 10 meters. I travel 10 meters from point A to point B. All right. Displacement is a vector. Okay. So a vector has direction. All right. So an example of a vector quantity that has direction is I travel 10 meters north. I travel 10 meters north. The direction is specified by that square bracket with n on the inside. Okay, so that's distance and displacement. That is a major difference between the two. One has direction, the other does not. Okay, what else can we say? The distance is the total path traveled. Total path traveled. And this is another major difference, because the displacement is just the change of position. It is an arrow from initial point to final point. That is the displacement. That is how much you've been displaced. You've gone from the initial point, the starting point, to the final point. Okay, so let's outline this with an example. Okay, so I am traveling from home, okay, to school. And what I'm going to do is I'm going to go this way, and then I'm going to go that way. So I'm traveling from home to school. I have to reach some intersection before I actually reach school. Okay? And let's say that this distance is 3 meters. And let's say that that distance is 4 meters. What I would then say is that the total distance that I've traveled is equal to 3 plus 4, which is 7 meters. I've traveled 7 meters. By the way, I probably shouldn't say 7 meters because that actually doesn't make any sense. There's no way that I travel only 7 meters. So why don't, instead of saying 7 meters, we say 7 kilometers. That's probably way better and more realistic. 7 kilometers. All right, so I'm traveling 7 kilometers. Now, the displacement is not 7, okay? The displacement is an arrow going from my initial point to my final point, okay? So this is the displacement vector. Now, a vector has a magnitude or a length plus a direction. So I need this guy's length. Luckily, we're dealing with a right angle triangle. So if we fire through and use Pythagorean theorem, we can determine the length of the hypotenuse, c. C squared equals a squared plus b squared. And we end up getting 3 squared plus 4 squared equals c squared. And c, after calculating, will end up being 5 kilometers. So I end up traveling through a displacement of 5 kilometers. But what direction am I dealing with here? Well, the direction is described by an angle theta. You see, I move in this direction for a certain amount, but then I move down through an angle theta. So I need to determine what that angle is. Luckily, if you've done grade 10, you can determine the angle theta using sohcahtoa because I'm dealing with a right angle triangle. So, how am I going to get angle theta using sohcahtoa? Well, let's go on to the next page. Let me redraw the triangle, or at least attempt to draw it. Okay. So this is going to be 3, and this is going to be 4 kilometers. And I found this to be 5 kilometers. And I want to find this angle, angle theta. Now, well, what I would first do is using this angle, okay, using that angle, I would label the sides. So 4 is opposite theta, so I call this side opposite. This guy is obviously the hypotenuse, and then I would use this guy as adjacent. I can use any trig ratio I want according to sohcahtoa. Okay, so the trig ratios are either sine, cosine, or tan. What I'm going to do is I'm going to use the tangent ratio. Tan theta equals opposite over adjacent. Opposite in this case is 4, and adjacent is 3. Okay, so 4 over 3 equals tan theta. So all you have to do now is determine what angle theta is. Okay, so we can use our trusty calculator and we can determine angle theta. So here we go. I'm going to run through the calculation. So I'm going to first do 4 divided by 3 in my calculator, and then I'm going to do second function tan, and I end up getting that theta is 53 degrees. Okay, so this angle, guys, this angle is 53 degrees. Great, so 53 degrees. Now let's say this is east, okay, and let's say this is south. What I've really done is I've moved east and then 53 degrees south. So this is my direction, guys. I've moved east first, then I've moved 53 degrees south. That is the direction in which I've moved, and the amount that I've moved in total is 5 kilometers. So right here is the displacement vector, because it has a magnitude and it has a direction. So that is a major difference between distance and displacement. Okay, so the distance involves just taking these two numbers and adding them, giving us 7 kilometers. However, the displacement is a little trickier. We have to actually find the length of the arrow using Pythagorean theorem, and that gave us 5. And we needed the direction. We needed to know the angle theta, which using SOHCAHTOA, we found to be 53 degrees. So after finding it to be 53 degrees, we can describe the direction east, then 53 degrees south. So our displacement vector is 5 kilometers east, 53 degrees south. So that's it. That's the major difference between distance and displacement. And that was outlined using an example 2. Okay, so there you go. Hope this video was informative. And I'll catch you in the next one, guys. Don't forget to like and subscribe. Peace out. Love you. Bye.